Hi, it's me, Dr. Prasad Puthiyillam. One more inorganic laboratory experiment, flame photometry. So, flame photometry, it is mainly used by environmental scientists to identify the metal ions present in the water sample. It can be used in regular chemistry laboratories as well as industries to find out the metal ions present in given sample of water or in a given sample. Okay, certain metals like alkali and alkaline earth metals, if you introduce it into a flame, that flame test already people know. So it will be emitting the corresponding wavelength of light in presence of the flame. That should be the flame temperature should be above 2000 Kelvin. So the characteristic radiation by an element which is which is in connection with or directly proportional to the emission intensity, that is the basis for or that is the principle behind flame photometry. So the sequence of changes which takes place if a metal ion is introduced into a flame or a metal salt is introduced into a flame, that can be represented like this. Mist represents we are introducing the metal salt as a spray into the flame, where the water, the solvent or water will evaporate, giving the solid state of that metal salt, then convert into gaseous state from which the metal will be excited. It will be converted into corresponding metal, and the electrons present in the metal will be excited by absorbing the heat energy to higher energy state. Immediately it loses the energy and come back to the normal state. So this coming back from the excited state to the normal state, it produces the electromagnetic waves it will be releasing. That is can be written like this: E2 minus E1, where E2 is the energy of the excited state, E1 is the energy of ground state, which is equal to h nu, where h nu can be rewritten as hc by lambda, or lambda wavelength of the light emitted will be hc divided by E2 minus E1. That means it depends upon the wavelength. For lithium ions, it will be producing a red color in the flame. Sodium ions will be producing yellow color. Calcium ions will produce orange or red color. Barium ions will produce green color. Copper ions, depending upon the concentration, it give blue to green based on the composition of the copper ion, blue to green color. And potassium ion will give lilac color. So we are not bothered about what type of color it is giving in flame photometry. Based on this color, we can keep the filters. Okay, so this is the instrumentation or instrumental setup of a flame photometry, where we are introducing the sample to a flame through atomizer with a mixing chamber, compressed one mixed with the fuel. So this is a compressor which compresses the air as well as the fuel mixture. So this one will give the fuel to burn the flame. Therefore, atomizer will take the sample, it will suck the sample, it will be mixed with the fuel, and that process we call as nebulization, and it will be introduced into flame at a very high temperature, around 2000, above 2000 Kelvin. So at the flame, the metal ions metal atoms will the electrons will jump to higher energy level and jumps back. It gives the corresponding wavelength of light will be emitted, which is passed through or which is concentrated through a lens, then using a slit, and appropriate filter is used based on the which wavelength of light it emits. So based on the sample we took, based on the metal ion we have to have a filter there to convert into a monochromatic light, which will avoiding all other unnecessary wavelength light. Only that particular wavelength of light will be concentrated to a photo detector, which will be amplified and will get the display of the reading corresponding to the metal ion present. So I can say that the concentration of metal ion what we take here into the flame, and the intensity, the display will be depending upon the concentration, how it is connected. The detector response, or DR, I can write as K into alpha into C, where K is a constant, alpha is efficiency of atomic emission, and C is the concentration of solution. So here it is clear that the detector response or the intensity of light given by the flame or given by the metal ion is directly proportional to concentration of the solution, or it is similar to that Beer's relation. So quantitative analysis, the quantity of the metal present in the solution, not only quality, it's quantity, how much amount is present, that can be determined by using flame photometry, can be carried out by calibration curve method. That means calibration curve method means we need to have a standard solutions of non-concentration. Concentration is taken in parts per million, ppm, that is milligram parts of solute per million parts of the solution. So initially we prepare 1000 ppm of metal ion, by then it is diluted to 100 ppm. Then how to prepare a 1000 ppm solution of corresponding metal ion or metal salt? We need to weigh, or we should know the formula weight of the metal salt divided by atomic weight of metal, that much gram if dissolved in 1 liter or 1000 ml with a deionized water, then it is a 1000 ppm solution. From 1000 ppm solution we can further dilute it to 100 ml, or we can dilute it to 100 ppm. For determination of potassium, the formula weight is 74.5513 divided by 39.03. We will be getting a value of 1.9071, that much gram of KCl. We have to take it in 1 liter, or we need to take 0.1907 gram in 100 ml, it will be 1000 ppm. So 10 ml from that, if you dilute to 100 ml, then it will become 100 ppm. That is simple mathematical calculation. For determination of potassium, we made the 1000 ppm, then further we convert into, we prepared 100 ppm solution. Therefore, the amount present in the initial 100 ml that we prepared, that will be weight of KCl, that is 0.1907, multiplied by atomic weight of potassium 39.1, divided by molecular weight of potassium chloride 74.56, we'll get a value 0.0996 gram. Therefore, amount of potassium ion present in the 10 ml of the solution, the 10 ml we took and we further diluted to 100 ml to get a 100 ppm. Therefore, present in the 10 ml solution, that will be 0.0996 divided by 10, that is 0.996 gram. And we need to find out the value of potassium present in 1 ppm or 1 ml solution, that is required for the further calculation to determine the unknown solutions concentration or amount. Therefore, 1 ml solution will contain 0.996 divided by 100, that is 0.00996 grams of potassium. Okay, in separate 100 ml standard flask, we need to prepare, okay, we have already 100 ppm solution, in which from, if you take 1 ml and dilute to 100 ml, it will become 1 ppm. Then if you take 2 ml and dilute, it become 2 ppm. Like that, 2, 4, 6, 8 and 10 ml solutions were diluted to 100 ml, and we have called them as the standard solutions with 2 ppm, 4 ppm, 6 ppm, 8 ppm and 10 ppm. Now the flame photometer, we need to calibrate the instrument. We need to get it ready for our estimation work. That means we need to set the value 0 with a deionized water. Deionized water does not contain any metal ion. Therefore, it should not give any intensity of light. Therefore, it is set 0. And a particular filter, potassium filter, we need to keep to filter the lilac, to get the lilac color concentration maximum. And we need to set 100 with the 10 ppm solution, that is this solution, the standard solution which we prepare with the 10 ml of solution. So 0 and 100 if you set, the remaining 2, 4, 6, 8, those readings, intensity reading, if you prepare the sample accurately, should come in between that of 0 and 10 ppm solution. Okay, therefore we can draw a calibration plot with the intensity values of the stock solution that we prepared. We'll be getting a graph passing through the origin, that is passing through 0. Now for unknown solution, whatever unknown sample given to us, or whatever unknown sample that we have, its intensity we need to measure. We need to take, aspire it into the flame, or we need to introduce it into the flame. Intensity reading, display reading will be given. That intensity reading we need to note down in the graph, and we need to draw a straight line parallel to the x-axis. Then where it intersect in x-axis, where it connect the x-axis, that is the concentration in ppm. Therefore, we already know how much 1 ml or 1 ppm contain. Therefore, whatever value obtained here, that is multiplied by the potassium amount in 1 ml, that will give the amount of substance present in the unknown sample. So that's about flame photometry with potassium as example. Hope you understood the concept and procedure and how to calculate it. Thank you very much for watching my video and have a nice day.